So balancing experiments, question number 2. The student is finding the weight of a meter rule or a meter scale using the balancing method. The apparatus is shown in figure 1.1. So you can see this apparatus is used in figure 1.1. So a meter rule is pivoted at 45 centimeter mark. A load is placed at P, another load is placed, a load Q is also placed at a distance Y. The student places a load P on the meter rule at 5 centimeter mark. She places a meter rule on the pivot at 45 centimeter mark. She places a load Q on the rule and adjusts the position so that the meter rule is near as balancing position, like it's almost balanced. She measured the distance X and Y between the center of P to the pivot and center of Q to the pivot. She repeat the procedure by placing a P at, so what she did, she repeat the experiment, like first she placed P at 5, then she placed P at 10, then 15 and so on till 20 centimeter, 25 centimeter. The readings are shown in the table. So for each value of X calculated, A equals to P into X, where P is equals to 1, and record the value. And where P is a load, like P is the weight of this load P. And for each value of a Y, calculated B is equals to QY, where Q is equals to 0.8, and Q is the load of the weight of the load Q. So first we have to complete, like how to get A. As I mentioned, A is equals to PX. So P multiplied by X, and the value of the P is given 1. So 1 multiplied by 40, what will the answer? You just have to complete, use the screen annotation, first complete this column. For each value, you have to, like example, first it is 40 multiplied by 1, so it will be 40. 35 multiplied by 1, so it will be 35.0. 30 multiplied, so it will be same as the value for X. And for value of a B, B is equals to Q into Y. What is the value of the Q? Q is not equals to 1, Q is 0.8. So 0.8 multiplied by Y. So 0.8 multiplied by 42.5. What's the answer? 34.0. Then same thing, 0.8 times 36. The second value, 28 point. Nineteen point two. And what about this one, the last one? 30 multiplied by 0.8. So it will be exactly 24. So we have the value for A and value of B. 40, 35, 30 was there. The reason why I'm writing these values because we have to plot a graph related to this. So this was 34, 28, 24, 19.2, and 14. The next part, complete the column heading. Column heading means like the units. What is the unit of X? X is a distance here on a meter rule. What is X? Meter, millimeter, centimeter. It is written 40. So it is centimeter. What is Y? The unit of Y. Because Y is also the length, so it is also centimeter. And what about the unit of A? Look, A is equals to P into X, where P is in Newton and X is in centimeter. So what is the column heading here? It will be Newton centimeter. And same thing, B is equals to Q into Y. So Q is in Newton and Y is in centimeter, so it is Newton centimeter. So when they ask column headings, you have to write the units. And according to the value, like X and Y are the measurement, the lengths are there. And on a meter rule, it's shown in centimeter, where A equals to load into X and B is equals to load into Y. That's why it is Newton centimeter. The next part, we have to plot a graph between A and B and start both axes from origin. So we have to start both axes from origin. What does it mean? Like you should start with 0, 0. Like this should be 0 here. There should be 0 here. Now, and for y-axis also there should be 0. When you check where we want to plot A should be on the y-axis and B on x-axis. So we want like our minimum, because we have to start from origin, so it means the starting value should be 0, but maximum we can reach about 34. So if I say this is 10, 20, 30, 40 and 50, and same thing, about 40 is there, so it can be 10 here, y-axis 20, 30, 40 and 50. And you have to label the axis. Like example, here it is A, and what is the unit of A? Newton centimeter. So one is for the like labeling the axis is of 1 mark. Then B is there, and what is the unit? Newton centimeter. Even you can see here, like A equals Newton centimeter, B equal Newton centimeter. So answer for this one, where you have to complete a column heading, it's given here within the question. So A is Newton centimeter, B is also Newton centimeter. Then we have to mark these points. So when A is 40, B is 34. So B is on the x-axis. So this one is 34 and 40. So 31, 2, 3, 4, 30. This is the first point. Then we have 35. Then we have 35 and 28. So 28 is, this one is 28 and 35. 1, 2, 3, 4, 5 and 28. Then 24, because B is on x-axis, so 24 and 30. So 1, 2, 3, 4, 24 and 30. Then we have 19.2. So 19 and 25. This will be 19, so 19.2 somewhat here. And then 20, 14 and 20. So 14 and 20. So these are the points which we mark. The next part, use a graph, determine the y-intercept. What is the meaning of a y-intercept? Y-intercept means when the value for the position where the line intersect the y-axis, that's called a y-intercept. So what we'll do, we'll draw a line of a best fit. Always try to draw a line of a best fit. And because usually in physics, usually the graph which you will get, it will be a straight line, but not always, but most of the questions, it will be a straight line. So if we draw the graph like this, like one point is above, one point is below, then this said that find the y-intercept. So how to work out the y-intercept? You extend this line. You extend this line until it reaches the y-axis. The position or the point where it reaches the y-axis, it reaches the y-axis, that is a y-intercept. So this value is a y-intercept for us. Is it clear? The y-intercept.
Yes, sir, clear.
So it is 1, 2, 3, 4, 5, about 5.5, because it is between 5 and 6, so it is 5.5. So use your graph, determine the vertical y-intercept and show clearly. So our y-intercept, for example, 5.5. Then the weight of a meter rule is equals to y divided by z. So y was 5.5 and z is 5. So 5.5 divided by 5, that's equal to
1.1.
1.1 Newton. Because the unit, as they ask for weight, so weight is in Newton. Then suggest one practical reason why it is difficult to obtain the exact result. Normally, whenever you're using a balancing experiment, the first thing, it is difficult to balance a meter rule when load is placed on it. So that is the first thing, like, because as you can see in the question, we place a load on the meter rule and we try to balance a meter rule or a meter scale. So it is difficult to keep the loads on the meter rule and keep it or make it balance. Because what happened, like you place load P and then you place a pivot. The moment you place this meter rule will topple. And so it's difficult to balance the meter rule when load are placed on it. And how we can overcome this difficulty? We can estimate the position before placing the loads. So difficult to balance the meter rule when the load is placed on it. And how you can overcome, they did not ask how to overcome, but how to overcome this? Estimate the position of loads before placing on the balance or before placing on the meter rule. So we just estimate, like, for example, if I'm placing A at, for example, as you can see, this one, we place, for example, we place at 40 centimeter mark, A, the load P, sorry. So load P, we place at 40 centimeter mark. So as we know, load P was, example, it was 1 Newton and load Q is 0.8 Newtons. So we should estimate the position before placing, like, as you can see, if this is placed at 40 centimeter mark, like it is heavy, 1 Newton is there, more heavier than 0.8 Newton. So lighter load should be placed away from the pivot to make the same turning effect. So means Q should be out after 40 centimeter mark, like distance of Q should be more than 40 centimeter mark. It cannot be within 40 centimeter or even 40 centimeter. Because when two loads, when we are doing the balancing experiment, even without calculation, we can have estimation that which load is heavy and which is lighter. Example, here's a pivot and we have two loads are there, example A and B. Because A is heavy, it is placed closer to the pivot, and B is lighter, so it placed away from the pivot to create the same turning effect or a moment. So to overcome this difficulty, when we have two loads and we want to balance a meter rule, we estimate the position, like we have an idea that if P is heavy, P I place at 40 centimeter mark, so Q is lighter, it should be definitely more than 40. It cannot be at 40 or within 40. A and B are the weights, and these weights are causing a turning effect. So we call moment due to A and moment due to B. There is a weight of A and there's a weight of A is equals to 1 Newton. Weight of B is 0.8 Newton. But as they are placed on the meter rule and there's a pivot, so these weights, which is a force, will cause a turning effect. One will cause a clockwise turning effect, another one will cause an anti-clockwise turning effect. To balance them on a meter rule or a meter scale, the clockwise moment should be equal to anti-clockwise. So if A is heavy, it should be closer to the pivot. The B is lighter, it should be away from the pivot. Is it clear this point?
Yes, sir, clear.
Student uses an accurate electronic balance to obtain the second value of a weight of a meter rule, which is 1.24. State and explain whether the two values are within limits Like our first value for weight of a meter rule was 1.1 and another value is 1.2. Can I say they are equal? Yes or no?
Yes.
1.1 and 1.2. How to do such question? If you want to compare whether they are equal or not equal, the simple rule, you will calculate a percentage difference. If the percentage difference between the two, whenever two, this is a very common question in which you have to compare the two values. How you will say whether, like, because looking at the values, estimation may not be 100% accurate. So what you can do, you can calculate the percentage difference. How to calculate the percentage difference? The percentage difference is equals to maximum minus minimum divided by the mean or the average into 100. That's a formula for percentage difference. And if the percentage difference, if your percentage difference is more than 10%, you will say, no, the values are not equal. But if the percentage difference of the two values is less than or equal to 10%, yes, we will say the two values are equal. So what are the two values? One of the value was 1.1, another one is 1.24. And we want to check whether they are equal or no. So formula for percentage difference, maximum. Which one is maximum value? 1.24 or 1.1?
1.24.
So 1.24 minus minimum value 1.1 divided by average. How to take average of these values? The mean. So 1.24 plus 1.1 divided by 2. What's the answer for average? 1.24 plus 1.1, which is 1.34. 1.34 divided by 2.
1.17.
1.17. So into 100. 1.24 minus 1.1. So the final answer is 7%. So the percentage difference is 7%. If the percentage difference is 7%, means it is less than 10%. So what we'll say yes. The statement like state and explain whether the two values of a weight agree within the limits of experimental accuracy. Statement yes. The percentage difference, you can write an answer here. The percentage difference is less than 10% between the two values. Your one is 11.9, but someone told me 7%. 1.21 minus 1.1. What's the answer for this? It will be
11.96.
11.96. Okay, so 11.96%. So we'll not say yes, we'll say no. Because this answer totally depends on your value, your previous value. So we'll say no. What is the reason? Because the percentage difference is more than 10%. So totally depending on your values when you're comparing. So that's how I'm saying whenever you look the numbers, you look like 1.1 is same as 1.24. But practically, like scientifically, you have to know the percentage difference. So percentage difference formula you have to memorize. That is maximum minus minimum divided by mean into 100. If your percentage difference is more than 10%, you will say no, the values are not equal. But if it is less than 10%, you will say yes, the values are equal. Is this clear? Comparison between the two values?
Yes, sir, clear.
Because for small values, even a 0.1 difference is big difference. Moving on to the next question, question 3. A student is finding the weight of a meter rule using a balance. So these all questions are related to balancing experiment. A load P is placed and another on a meter, a pivot is there and a weight of a meter rule. The weight of a meter rule will cause a clockwise turning effect and a weight of a P will cause an anti-clockwise. If their moments are balanced, the rule will be balanced on it. The student places a meter rule on a pivot and place a load P on the meter rule at 90 centimeter and he keep the load at 90 centimeter and he adjusted the meter rule until it is being balanced. Then he record the distance. He record the distance B from pivot to the mark 50 centimeter mark. And then he repeat the procedure by placing a load P from 85, 80, like he changed the position of load. First it was 90 centimeter mark, then he placed at 80, then 85, 80. He repeat the steps by placing, as we mentioned, readings are there, A and B. Then we have to plot a graph. So I will write these values. 21, 18, 16, 13, 10.5, and B is 19.1, 17.2, 14.1, 11.8, and 9.5. So these are the values for A and B. We have to plot a graph for A on y-axis and B, and you do not need to begin. So here they mention no, here what is happening, if A is decreasing, B is also decreasing. You can see why A is decreasing, B is decreasing, because the idea is that, see, we have a meter, we place a load P here, and there's a pivot, and there's a weight of a meter rule acting downward. Say the first it was 21, this distance was 21, and weight of a meter rule at a distance of 19.1. This give an idea that meter rule weight should be more than P, because this is, now what happened if we move P closer? If P is further, like closer to the pivot, this is 18. So to create a same, because we reduce, when we move the P closer to the pivot, we reduce the turning effect or moment. So the weight should also be closer to the pivot so that it will also reduce its turning effect. So when we are decreasing a value of A, the value of a B is also decreasing. Same way, if A is much closer, like A is very close, so B should also come closer to create a same turning effect, because the value of the B should be less than A, as we know, identify that A is lighter because it's having a greater distance, and B is heavy as it is having a further from the pivot. So in the question they mentioned we not need to begin the accesses from origin. Look, means we don't have to mark 0. Like we don't have to start with 0. We can start with any number. That's the meaning, that don't start with 0. Some student think that they no, don't start with origin. They mean like don't start the graph from origin. It's not like this. It's mean like you don't have to label the axis from origin. So just check the minimum and the maximum value. For B, A should be on y-axis and B on x-axis. So for B, if I check the values, my minimum value is 9.5 and the maximum is 19. So if I start with 9, 10, 11, 12, 13, 14, 15, it won't fit. But if I select, like example, 9, 11, 13, 15, 17, 19, 21. So this is for B. The minimum value, because I include like extended the scale and started with 9 and ending at 21. So I will have all these. For A, it is starting at 10.5. So I can start, like example, with 10, 12, 14, 16, 20, and 22. (16, 18, 20, and 22). So we label the axis. Now we have to mark the points 19.1 and 21. So 19 is this. This will be 22. This will be 21. And 19.2 will be somewhat. So 19.2 is there. So on x-axis, 10 boxes equals to 2. So each is representing 0.2. So this is 21, like this value is 21. So I have 21 and this is 19.2. So between them, 19.1 and 21. Then 17.2 and 18. So this was 18 and each box is representing 0.2, so 17.2. And 14.1. So this is 14. And 16 was there, so 14.1. So this will be 14.1. Then 13 and 11.8. 11.8 and 13. And I should label this as well. So 11.8, this will be 12. 11.8 and 13. And then 10, 9.5 and 10. So 9.2, 9.4, 9.6. So this will be 9.5. And the other value is 10.5. So because each is equals to 0.2. So 9.246, 9.5 is there. This will be 10.2. And I need 0.5. So somewhat here it will be 0.2. Now what we have to do, you have to, again, as I mentioned, draw a line of a best fit. So line of a best fit, the number of the points above and below should be equal. So as you can see, like one point is here, another point is below, and so one point, this point is above, this point is below. So I draw a line of a best fit. So in physics, whenever you're drawing the graph, you try to draw a line of a best fit. Is it clear? Plotting these results?
Yes, sir, clear.
The line of a best fit means like the number of the points above and below should be same. So as you can see, if I draw or join by a free hand, so how I will draw like this. So that is wrong. So what I have to do, I have to draw a line of best fit. After marking those points, we try to draw a line which is having like equal distribution of the points above and below. It's not like all the points you should touch, but the idea is that it should have a number of the points above and below should be same. So if you see this line when I draw, this is one point is above, one point is below. So they cancel out. Second point is above, second point is below. So they cancel out. So the line of a best fit is the one which is having equal distribution of the points around it. The next part we have to calculate the gradient, and whenever a gradient is there, it means it should be a straight line. So we have to calculate a gradient. For calculating a gradient, you have to show that working on your graph. Like you have to take any other points. Example, I took this point. So first point on x-axis, I will say x1. The first point on y-axis, I call y1. Then I'll take another point. So I took this point. So second point on x-axis, I will call that as x2. And the second point on y-axis, you have to show this on your graph. Like you have to draw these lines. If you don't draw, you will not lose the mark. If you just use a formula y2 minus y1 over x2 minus x1 without mentioning on the graph, you will not score the mark. So y2 is how much? It is 21.8. y1 is how much? It's 12. x2 this is 17, this is 18, and x1 is 11. So when we simplify, 21.8 minus 12, it will be 9.8 divided by 7. 9.8 divided by 7, what's the answer?
1.4.
1.4, so we'll mention that the gradient is equals to 1.4. So remember this, you have to show this on your graph. Like if you don't represent on the graph, you will not score, you will lose a mark for that. So you have to show that, and don't take the same points which you use for labeling. Like we use these, some student, what they do, they take the same points which they plotted. You cannot take the same points. You have to take two different points. Yeah, you can take any points. But for accurate result, for more accurate result, the distance between the points should be 5 centimeter for accurate. So we got the weight, which was 1.4. So we'll write here that our answer was 1.4, the gradient. Then calculate the weight W1 of a meter rule, that gradient multiplied by P. So gradient was 1.4 and P is 1. So 1.4 multiplied by 1. So it will be 1.4 and the unit should be Newton. Suggest one practical reason why it's difficult to obtain accurate readings of A and B in this experiment. The same answer what we did for balancing experiment. What is the practical difficulty? The practical difficulty is difficult to balance the load. Why C is of 2 marks? 1 mark is for mentioning the unit. When you write the unit, you will score 1 mark. When you write the value, you will score the second mark. So one practical difficulty when we carry out this experiment. So difficult to balance the meter rule when the load is placed on it. So that's a practical difficulty. And how we can overcome this practical difficulty? By estimating the position of a load. Then the student measure the mass of a rule by using a balance. It is 112.65. You have to write to a nearest gram. What is a 112.65? What is the nearest gram? Whole number. So yeah, that's right, 113. So 113. Now calculate the weight of a meter rule. Weight is mass into gravity. But this mass is in gram first, because you have to use a formula W is equals to mg. But mass is in gram, you have to first convert into kilogram, divide by 1000. So it will be 0.113, divide by 1000. So it will be in kilogram, and multiply by gravity 10. So it will be 1.13 Newton. State and whether the value of a W2 can be considered as W1. What was the value for W1 for us? The W1 was 1.4 and W2 is 1.3. So here, even while looking at this, I can clearly tell they are not equal. Like one of the value, the value for W1 when we did using a graphical method, it was 1.4, and the value for W2 is 1.13. Are these values equal? Because sometimes when you look at the value, you can easily identify when they don't look like too big differences there. So can I say 1.4 and 1.1 are equal?
No.
So no, they are not equal. Like it's a very big difference is there. So you can say according to your answer, like example, it's always a comparison is there. You will always compare, because this answer can be yes, it can be no. Because for some student, maybe their last answer was say maybe 1.1 Newton. So if their last answer was 1.1 Newton and this is 1.13, so they will say yes. But for us, because we are comparing with our value, which is 1.4, so we will say according to our value, not about the marking scheme. It totally depends on your value. The comparison between the two totally depends on your values. So you will say no, the two values like within limit of experimental accuracy, the two values are not equal. Or this is the two values are beyond the experimental accuracy. Is this clear?
Yes, sir. Clear.
Okay. So